This is a ickier problem because we're not talking about squirrels. In addition to that, they've snuck in a 2x in front of this, meaning that this part's clearly a derivative, right? To integrate to get to g of x. But you got this 2x in front that's going to cause us some confusion and pain and suffering. But let's see what kind of pain and suffering it is. Let's start off with, let's read this thing. This right here is a quarter circle of radius 3. That's what it says in the problem. This is a quarter circle of radius 1 in case I need that. Anything else I need? Oh, a reminder, if this is the derivative, then the area is g of x, sort of, because remember, there's a 2x sitting out in front. And then the second derivative of g of x is going to be the slope, right? So that's what I think of term. And the derivative is what you see. What you see. Not counting this 2x that's out in front that's causing me some grief just looking at it. All right, so we're going to start off with A. A says, find g at -3. Well, I'm just going to go ahead and say, well, g at -3 is equal to 2 times -3 plus the integral from 0 to -3 of f of t dt. I'm going to go ahead and do that. I get -6. How do I do the integration for this? It's just the area of the curve. The area of the curve would be, so the area of the curve is pi r squared. 1/4, because it's a quarter of a circle, right? Not a half or anything. 1/4, the radius is 3, so that's 9 pi. So I get 9 pi, 9/4 pi. So far, so good. Now, there is a glitch in the matrix. What is the glitch in the matrix? The glitch in the matrix is we are, in fact, going backwards. What? We started here and we started going this way, correct? If we started here and went this way, that means we're going back in time. Remember, the area of the curve is how, let's say you're filling a tub with water. At t equals -3, we are filling the tub with water until I get time equals t equals 0. So if I go backwards in time, I run the tape backwards, I would lose the water I'm putting in the tank. So this actually ends up being a negative. Okay, and we're still not done with this problem. Isn't that lovely? Find g prime of x. Well, let's go get b. Let's go ahead and g prime of x. G prime of x, we take the derivative of that function, which is 2. Plus the derivative of the integral is just the function itself, so f of x. Right, derivative of the integral gives you back the function to begin with. So if I want to find, so that's the second question. And the third question is find g prime of -3. Well, g prime of -3 would be 2 plus f at -3. Well, what is f at -3? I go look at the problem. F at -3 is 0, right? So this is just going to be 2 plus 0 or 2. All right, that's just A. We're getting a lot of this problem. B, determine the x-coordinate for which it has the absolute maximum on the interval from -4 the absolute maximum between -4 and 3. Justify your answer. So I look at the problem and go, all right, well, g of x, if I want to find the maximum of that, I got to do g prime of x, right? So I'm going to take the derivative of this. We just took the derivative of this. It's 2 plus f of x, correct? So I want to set the derivative equals 0, so that's going to be 2 plus f of x. So I get -2 equals f of x. And so I got to figure out where it's equal to -2. Well, it's clearly above -2 all the way over until it gets to right about here somewhere, correct? So I figure out where it is -2. A couple ways you can do it. The brute force method is, let's find the equation for that line. It's y equals the slope. It goes down 6 and 3, right? So it's going down 2. So -2x plus the y-intercept is 3. So I'm going to plug in, I want to solve for when it gets to be -2, right? So -2x plus 5, plus 3, sorry, plus 3. So I get -5 equals -2x, and I get x equals 2.5, okay? So x equals 2.5. Now, before that, g prime of x is greater than or equal to 0 before that. Why? How do we know that? Because it's always above -2, right? So the value is going to be above 0, right? Because you're going to subtract 2 of it. So 2 plus whatever this is, Over here, it's -1, fine. -1 plus 2 is still greater than 0, right? So it's positive, increasing, 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 increasing. Somewhere right about here, it goes to decreasing, right? So, and that's so from -4, let's actually make a curve bracket just to be careful, to 5/2, or 2.5. And then from 2.5 to -3, yes, or +3, that would be better to write +3 because that's where that is. It's g prime of x is going to be less than 0. So it's increasing before, decreasing afterwards. It must be an absolute maximum at 2.5. Whew, sweating. Okay, I need some more room, so I'm going to clear my board. Let's see, file new, clear, save. Here we go. Let's see, I can paste. There it is. All right, good. All right, so now it says here that we've got C, find all values of x, from -4 to -3, for which the graph of G has a point of inflection. Give the reason for your answer. Points of inflection is when your second derivative. Okay, so first of all, let me back up. G prime of x is what you're looking at. Read graph. 2 plus f of x, right? So that's how we found the derivative. G of x is area plus 2x, right? And G double prime of x is going to be slope. If I take the derivative of that 2, it goes away. So we're just looking for the places where the slope. So second derivative refers to slope. So I'm looking for places where the slope is 0. You see any? I don't see any. Or where the slope is undefined. Aha! My pointy point up here, which is probably bothering you in the previous problem, that is a place where it's undefined. Not only that, but the slope goes from increasing to decreasing, so therefore the second derivative goes from increasing to decreasing. Write that all down, put it in a bow, that's how you've got C. So you would say something like, from -4 to 0, not including those two, G double prime of x is greater than, greater than or equal to 0. Okay? And again, and then you'd say from 0 to -4, 0 to positive -3, G double prime of x is therefore less than 0. Therefore, it goes from concave up to concave down. I'd also bother to show that, I took the derivative, G double prime of x is equal to f prime of x, right? Because the 2 gets dropped. You take this and take the derivative. I would do that. Okay. All right, so the average slope, average rate of change on f on the interval from -4 to 3. Now notice I dropped G altogether, because thank goodness G is getting my head to melt. It says, and then find the point that -4, between -4 and 3, for which the average is equal to instantaneous rate. If there is no point. Sorry, let's back up. Let's read the problem. It says so in there. The average rate of change of f on the interval from -4 to 3. Find it. Okay, so from -4 to +3, we went -3 minus 1, minus a -1, should say, all over 3 minus -4. So we went down 2 over 7. That's our average slope, right? Average rate of change. It's the same thing, just for f, right? Then it says, explain why. Then it says, but no place is the derivative of -2/7. Since the mean value theorem says you have to have that, right? We don't have it. Why don't we have it? Well, what are the restrictions on the mean value theorem? The restrictions on the mean value theorem are, it must be continuous. F of x is continuous. It must be differentiable. At x equals 0, f prime of x is undefined. because f prime of x less than 0 f prime of x is less than 0 when x is less than 0. I should be more careful. I should put it on greater than -4, as it were. And that's not true. It's greater than 0. And f prime of x is equal to, we solved for the slope just a second ago. I just deleted it. What was the slope of that line? The slope of that was negative down 6 over 2 over 3 over 2 over 3. Down 6, so -2. When x is greater than 0, oh boy, that's a great win. Let's write it better, sorry. When x is greater than 0, but less than -3, okay? And so those two cannot be the same, therefore you've proven there's a point of discontinuity at that point for the derivative. So the derivative does not exist, therefore the mean value theorem does not exist. Okay? All right, we've got it. This one's nasty, I admit it. I like it as an example problem because sometimes it's the kind of dumb stuff they throw at you, so it's got everything in it. So, post your questions if you got them.